BlueZoo offers 4 sensor calibration options to enable accurate audience measurement in various environments. Sensors are individually calibrated to define the desired detection zone. Sensors are configured to define an inner and outer perimeter as shown in this slide. Sensors with omnidirectional antennas have spherical detection zones. Sensors with directional antennas have conical detection zones. The perimeters can be calibrated to be from 4 meters to 100 meters from the antenna. Calibration determines the power level, expressed in decibels, that corresponds to the desired perimeter distance as well as advanced parameters that suit the sensor environment. Lower power levels correspond to more distant perimeters. Higher power levels correspond to nearer perimeters. For example, an inner perimeter might correspond to -70 decibels and an outer perimeter might correspond to -120 decibels. BlueZoo sensors can be calibrated in 4 ways: distance-based calibration, range detection-based calibration, ground truth-based calibration, and manual calibration. This demo will briefly explain each of these 4 calibration methods. For each, we will assume that an omnidirectional antenna is being used. Let's begin with distance-based calibration. This calibration method determines power levels based on standard distance power curves for each type of antenna. Firstly, measure the radius of the inner perimeter of the detection zone. Next, using the BlueZoo mobile app, log in and select the sensor location to be calibrated. Finally, choose Distance Calibration. Select your sensor's antenna type, internal or external, and the units of distance measurement. Enter the distance with your keypad or adjust the slider to the desired inner perimeter distance. Click Apply Distance Calibration to set the power level in decibels corresponding to your measured distance. The second calibration method is range detection-based calibration. This calibration method accounts for anomalies, like furniture or walls, in the detection zone. Using this method, the installer walks the inner perimeter, and using the BlueZoo mobile app, instructs the sensor to record the detected strength of Wi-Fi probes sent by the installer's phone. This method is very useful for determining if the perimeter of the detection zone corresponds to a consistent power level. Using the BlueZoo mobile app, select a sensor location and navigate to the Range Detection Calibration section. Select Enable Wi-Fi Access Point, and the sensor will broadcast its SSID. The sensor will continue broadcasting its SSID for 30 minutes after the installer's phone last interacts with the sensor. Next, open the Wi-Fi settings on your smartphone and connect to the sensor's access point. The access point's SSID will start with @blue and will end with the last 4 hexadecimal digits of the sensor's MAC address. No password is required. Now, return to the BlueZoo mobile app. At each point on the inner perimeter, click on the Measure button to capture the power level measured by the sensor. The installer will walk along the inner perimeter and have the sensor record the power levels of the installer's phone that the sensor sees. Ideally, walk the entire perimeter. Once readings are complete, view the statistical results, including minimum, maximum, average, and median values for your set of measurements. Most often, installers should choose the average value to calibrate the sensor. Finish setting up the inner detection range. Optionally, you can calibrate the outer detection range by selecting Measure Outer and following the same steps. but this time measuring Wi-Fi signal power at the perimeter of the outer detection zone. The third and most accurate calibration method is ground truth-based calibration. With this calibration method, the installer manually counts either the number of people instantaneously in the detection zone, or the number of people entering or leaving the detection zone over a period of time. These two kinds of ground truth are called head count snapshots and threshold counts. Ideally, ground truth is collected when many people are present in the detection zone and when few people, but not zero, are present. Head count snapshots are necessary to calibrate visitor counts. How many people are present at a moment in time? Threshold counts are necessary to count visits. How many people enter and leave the detection zone during a period of time? BlueZoo recommends that multiple counts of each type are performed when visitor counts are both high and low. Each threshold count should take place for at least 15 minutes. Once ground truth data is collected, this data is fed into a calibration job, performed in BlueZoo servers in the cloud, that seeks the computation method and calibration parameters that causes the sensor to deliver results that most closely match the ground truth. Please view our ground truth-based calibration video for a more in-depth demonstration of the ground truth calibration. The fourth and final calibration method is manual calibration. This calibration allows an installer to manually apply calibration settings, originally determined for one sensor, to other sensors without measurement or ground truth collection specific to that sensor. It's common that many sensors in an environment will use the same calibration settings. Manual calibration lets you carefully measure ground truth for one sensor and apply calibration job results to many sensors. This calibration technique can also be used by experts to fine-tune a calibration already applied by tweaking calibration parameters. In summary, distance-based and range detection-based calibration options are fast and easy, ideal as first-pass solutions. They are particularly useful in environments where collecting ground truth data is challenging. Nonetheless, ground truth-based calibration remains the gold standard. Often, a dual approach incorporating both range detection and ground truth collection methods is best. The power levels measured through range detection can aid in selecting the optimal candidate from the ground truth calibration results.